All right, test 1-3 review. So graph the transformed function given g of x. So here's g of x. Let's identify the transformation, right? So this negative out front, this is going to reflect it. Across, so it's vertical, right? So it's vertical, so it's this way across the x-axis. And then the +3, again, this is outside of the function, right? It's away from the x, outside the function. This is a shift up 3. So let's reflect it and then shift it. All right, so this point here is 5 units down, so it's going to get reflected up 5 units. So I always reflect first and then shift. Reflect, then shift. 1, 2, 3, 4, 5. So reflecting it puts it here, but then we need to shift it up. So we'll shift it up 3. 1, 2, 3. That's crazy. All right, the point that's on the x-axis, again, reflecting it does nothing, but it shifts up 3. 1, 2, 3. So we can connect that dot. This next point, again, reflects up. So it's going to go here, then we move it up 3. 1, 2, 3. The y-intercept, it gets reflected down. So it gets reflected down 2. And now we have to shift up 3. So 1, 2, 3. So this is prime example of reflect first and then shift. Because if you shift first and then reflect, it would have been a different spot. All right. So this point here, we're gonna reflect it down. So 1, 2, 3, 4. And then shift it up. 1, 2, 3. The next x-intercept. So it doesn't get reflected. It gets shifted up though. 1, 2, 3. And then the last point. This gets reflected up. So 1, 2, 3. And then shifted, or it gets reflected and then shifted up. 1, 2, 3. All right. So there it is. In red is the graph reflected and then shifted up 3. So it's flipped and then shifted up 3. All right, list all the transformations of g of x that apply for the following. So this gets reflected across the x-axis because it's outside, right outside of the function. So the g, that's not being multiplied, right? It's not like g times something. The g is the function, right? G of x. We don't know what the function looks like. We don't care what the function looks like, but we know what's happening to the function. It gets reflected across the x-axis. Let's switch the colors. The 2 is going to vertically stretch, right? Because it's outside the g of x, and it's a number bigger than 1, so it's a stretch. It's going to behave how you would think. The +1 inside lies. This is a horizontal shift to the left 1 unit. And then lastly, outside This is a vertical shift down. Two units. So there's four things here, right? It reflected across. It's a vertical stretch because it's outside. Behaves normally. Inside the g of x, right? Inside the g of x, inside the function, inside, the inside lies, so it's opposite. And it's all horizontal movements. So horizontal, shift left, 1. And then a vertical shift down because it's outside. All right, number 3. Select the statement that is true for this function. All right, so let's just look at these individually. Vertically translated up 3 units. So vertically translated up 3 units. That's not true because an up would be outside, right? This plus 3, don't fall for it. All this is inside. All this is horizontal movement. This is all horizontal movement. Okay, vertically translated. So it's not A because it's not vertically translated. Again, it's not B because it's not vertically translated. Vertically reflected across the x-axis. For that to be true, you would need a negative outside in front of the 2. So it's not that one. Horizontally reflected across the y-axis. That's going to be this negative right here. So yes, this is D. So here's something to consider. The function, if you factor out the negative, you get x minus 3. So this is a horizontal reflection across the y-axis, and then this is going to shift to the right 3 units. Okay. Let's see. All right, given the 2 graphs, write the equation for g of x in terms of the transformation of f of x. Okay, so f of x is going to be transformed, right? F of x is like the parent function. G of x moves it. So let's look at kind of like the center spot here. So it's going to go what direction? Right, it was, let's see, it was here. And then we went up 1, 2, 3, up 3. So up 3. And then to the left, 1, 2, 3, 4, 5. To the left, 5. So inside has to lie. So plus 5 because we went left 5. And then we'll call it F, right? F. Now, let's see what kind of stretches we got. So this is going to be, so first let's look at horizontal stretch, if there even is one. So I'll just go from here to here. So this is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9 spots. So let's check from here to here. 1, 2, 3, 4, 5, 6, 7, 8, 9 spots. So there was no horizontal stretch or shrink. It stayed the same horizontally, right? It stayed the same. Now let's look at the verticalness. So let's go from here to here. 1, 2, 3, 4. Let's go from here to here. 1, 2, 3, 4, 5, 6, 7, 8. So it doubled. It went from 4 to 8. So doubling would be a 2. All right, that's it. Hopefully you understand how transformations work. All right, number 5. So this particular problem, the letters are kind of jacked up. So let's explain. So here in red, this is outside the function. So this is a vertical. Here, look, let's do it over here. So first off, we have a vertical shrink by a factor of 1/2. Vertical shrink by a factor of 1/2. That's what's happening in red. So vertical shrink by a factor of 1/2. All right, C. Okay, we have a reflection. It's a horizontal reflection across the horizontal reflects across the y-axis. So this is where it's kind of messed up. So this is going to be the y-axis here. Even though this says y-axis, that should be switched. Or the vertical and horizontal could switch. This takes less correcting. So B, horizontal reflection across the y-axis. Okay, the 5. This is it's inside lies. So it's a big number. So that means it's going to shrink horizontally. Horizontal shrink by a factor of 1/5, right? Because inside lies. It's the opposite of everything that we think. So to make this true, we're going to correct this. This should be a 5. So horizontal shrink by a factor of 1/5, right? Because it's the opposite of 5, in a sense. Okay, let's go back to red. So this is going to be a shift to the right. Translated right 3 units. So translated right. And then lastly, in blue, we went down 2. Translated down 2. So Q. So notice there's 1, 2, 3, 4, 5 transformations. So we need to select 5 things. Hopefully you get that. All right, describe the following changes in the following equations, or describe the changes of 2f of x in the following equation. Okay, identify if there's a horizontal shrink, stretch, and give the factor. Bet. So it's 4, right? Big number, inside lies. So big number is a shrink by a factor of 1/4. All right, it's a shrink, and the factor is 1/4. All right, B, identify the vertical shrink or stretch. Give the factor. All right, outside the function, outside of f of x, we have 1/3. So this behaves how you would think, right? It's a fraction, so it's definitely going to shrink. It's smaller than 1. Smaller than 1 is a shrink outside. And that factor is exactly what you think it would be, 1/3, right? Outside the function, it behaves normally. Inside the function, everything is backwards. Across which axis is the reflection? Okay, so the reflection is outside. Anything outside is vertical. Vertical's up and down, so it reflects over the x-axis. Identify the translations. So the translations are going to be inside lies, so right 1, and then down 6. Too easy. Right 1, down 6. All right, number 7. Graph this guy here. Okay, so we treat absolute value like we would any other parent equation, right? Or any other equation. Inside's going to lie. The vertex can be identified. So this is the x component of the vertex. So -4. So vertex is going to be -4, comma 3. -4, comma 3. So -4, 1, 2, 3, 4, up 3. So left 4, up 3. 1, 2, 3. All right, so here's the vertex, right, just from looking at it. And we know that absolute value looks like this. However, it's reflected down. So this is reflected down. Okay, so since there's no stretch or shrink, it's going to be at a 45-degree angle. So slope is like down 1 over 1. We want to keep going? Sure. Show at least 5 points and give the coordinates of the vertex. Yeah, that's what I did. All right. Number 8. Oh, this is easy. So first off, remember, all absolute values must be positive. All absolute values must equal something positive. So when you see this negative, it's so easy to just jump to, oh, it's no solution, right? No solution. That's not necessarily true. And it's because you have other things happening to the absolute value. Now, if that wasn't here and the absolute value was all isolated by itself, then yes, you'd be correct. But let's see what happens. So I'm adding two things. Like I'm adding -3 to the absolute value. So I want to get rid of the -3. So you have to do opposite of this. But I have to add 3. You have to add 3 to both sides. So we get absolute value of 4 minus 5x is going to be equal to -6 plus 3, which is -3. So you have to be sure that you're doing the correct operation. Don't subtract 3 here. Like you have to take it away, right? You have to do opposite of whatever's happening. So it cancels. So now we have an absolute value is equal to a negative number. And as we mentioned, this must be positive. Right? There's no value for x that we could plug into this that the absolute value would then be a negative number. Right? It's just not possible. No solution. So it was no solution. If you would have jumped, you would have jumped correctly. You would have guessed correctly. But we don't want to guess, right? We want to be 1000% sure. All right, solve for x again. Again, I'm going to add 3 to both sides. I got to do the opposite to isolate the absolute value. So we get absolute value 4 minus 5x, which is equal to 11 plus 3, 14. All right, absolute value is isolated. It equals a positive number. So we're good. We can move on to the next step. We have to split this up into 2 equations. So 4 minus 5x equals 14. And 4 minus 5x equals -14. Right? You always want to split up into 2 after you've moved everything and isolated it. So this is -4, -4, -5x equals 10. Divide by -5. X is equal to -2. So that's one equation, or that's one solution. On the right, -4, -4, -5x is equal to -18. 18. And we get divided by -5, -5. So x is equal, negative divided by negative is positive, 18 over 5. That is not reducible. It says reduce as possible. If you run into fractions, you know, it is what it is, right? Just that's the nature of the beast. So, okay, here comes a slightly harder one. Let's not get confused. Let's stick to the script. The left side's positive, so we're going to break this up into 2. I'm going to switch colors. So this is already isolated. We get 3x plus 1 is equal to x plus 2. And then 3x plus 1 is equal to negative, parentheses, x plus 2, right? You got to take the negative of the right side. You know, just like we did -14 in the previous problem. We take negative x plus 2. That negative is going to distribute here in a moment. So combining like terms, minus x, we get 2x plus 1 equals 2. We subtract 1 from both sides. We get 2x is equal to 2 minus 1 is 1. Divide both sides by 2. X is equal to 1/2. Now, the only difference is here, we just can't say, okay, yeah, this is the answer. Here, because there was a variable outside the function, outside the absolute value, we have to check our answer. So we plug in 1/2. So when I plug in 1/2, 1/2 plus 2, well, it's 2.5. So 2.5. On the left side, 3 times 1/2. So what's half of 3? 1.5. 1.5 plus 1 is 2.5. Absolute value of 2.5 is positive 2.5. So 2.5 is equal to 2.5. X equals 1/2 is definitely an answer. All right, let's check this side. Distribute 3x plus 1, negative x, negative 2. Going to add x to both sides. So this is 4x plus 1 is equal to negative 2. Minus 1 minus 1. 4x is equal to negative 3. Divide both sides by 4. X is equal to negative 3/4. So let's check that. All right, let's check that answer. Negative 3/4. Negative 3/4 plus 2. So this is going to be 1 1/4. So 1.25, right? Because 3/4 is 0.75, 75 cents. So 2 minus 75 is 125. All right. On the left, inside the absolute value, all right, this is going to take some work. So this is going to be 3 times 3/4. 3 times 3/4, negative 3/4, is negative 9/4. So negative 9/4 plus 1. Holy crap. So negative 9/4 plus 1. I need a common denominator. So 4/4. So this is going to be negative 5/4. So negative 9/4 plus 1 is equal to negative 5/4. So fourth is 0.25. Yeah, so negative 1.25. That's what negative 5/4 is. All right, absolute value of that will turn it positive, and it just so happens that that's also a solution, right? Because it equals the same on both sides. Okay. Let's see. Why do these look alike? 11. What's happening? Okay, I see what's happening. So number 11, you just can't say, well, first it's an inequality. So the idea is that I'm going to split this into 2, a positive and a negative, but only if this is positive. Right now it's not. However, there's a negative in front. So we have to divide both sides by negative 1. I'll switch colors so the math doesn't get blurred. All right, negative 1. So this is going to be the absolute value of 1 plus 3x less than, well, it's not less than because we divided by a negative. So we got to flip the sign. So greater than positive 23. Now, it almost looks like this one. So let's flip the signs here. Let's flip the signs. Not flip the signs. We flip the sign, so it's absolute value of 1 plus 3x. Now I'm going to split it into 2. So we have 1 plus 3x greater than 23, and then 1 plus 3x. Flip the sign, less than, make it negative 23. So flip the sign, make it negative on the second one. All right, minus 1. 3x greater than 22. Divided by 3. This is going to be x greater than 22 over 3. All right, for the right equation, minus 1 minus 1, 3x less than negative 24. Divide both sides by 3. X is less than negative 8. All right, so these are the solutions to number 11. All right, for number 12, which is oddly the same. I wonder if I can cheat a little bit. Can I cheat? If we change these signs, what do we get? So I'm going to cheat a little bit, my bad. All right, so for number 12, this is greater than, or less than, I'm sorry, less than, because the little side's to the left. So it's already positive, it's already isolated, so less than. So this is going to be less than. Okay, for the other one, we have to flip the sign. So we'll make it greater than negative 23. This would be greater than, and then this would be greater than. So the signs are backwards. That's weird that they would do that, but you know, they can't outsmart us. They cannot outsmart us. Okay, number 13. For each of the equations below, find the vertex. Determine what form the quadratic equation it is. Determine the domain and range. Find the y-intercept. Graph the equation. Write the equation in standard form if it is not already in standard form. All right, so look, we got 3 forms here. First form is the vertex form. How do I know it's the vertex form? Because we have this x squared piece, and then, so h and k, right? H and k. I mean, this is just what the vertex form looks like. Like, I know you're just learning this probably for the first time, but eventually you just recognize it. All right, this is going to be the x-intercept form, right? Because these are the x-intercepts. And then the last one, this is the standard form. Standard, because it's the x squared, the x, and then a c value. Okay, so for each one, we need to find some things. All right, the vertex for the top one, I'll keep all the colors the same. So the vertex, inside lies. So positive 2, outside tells the truth, 5. Vertex is at 2, 5. We already said it's in vertex form. Determine the domain and range. Domain, always, all real numbers. So, right, a quadratic is continuous, so the domain is infinity to infinity. Negative infinity to infinity. The range, however, okay, so this is going to take some brain power. This is negative, so it opens downward. Right, it opens downward. So that means it's going to have a max. So the range is going to go from negative infinity up to the max. Matter of fact, it's going to go to the y component of the max. So this is going to go from negative infinity, because it goes from bottom to top, up to the y value of the vertex. So 5. With a bracket, because it's continuous, right? It's included. Y-intercept. The y-intercept is when x is equal to 0. So if we let x be 0, right, x is 0, we get negative 3, 0 minus 2 squared plus 5, which is negative 3 times negative 2 squared plus 5. Negative 2 squared is going to be positive 4. Negative 3 times 4 is negative 12 plus 5 is negative 7. So what do we find? When x is 0, y is 7. So this is the y-intercept. Y-intercept is when x is 0. And then graph the equation. We're graphing it. You know what it looked like. All right, I'm not worried about that. So, I'm thinking we have to write it in standard form if it is not already in standard form. Okay, so it's not in standard form. All right, so this is going to take some work. So this is going to be, if I can zoom in. All right, so the way we do this is going to be -3. X minus 2 squared. That means there's 2 of them. Plus 5. So we have to FOIL this out. Double distribute. So this is going to be -3. And then the product of these two are going to be x squared plus 4 plus 2 times x times 2. Okay, so this is going to be -4x. There's a little trick on that later. If you FOIL it out, that's what you'll get. I assure you. All right, now we distribute the 3, the -3. So we get -3x squared minus 3 times 4 is 12 plus 12x. Right, that's after you distribute, and then the plus 5. So now we combine all the things and then we write it in the proper order. So -3x squared plus 12x, -12 plus 5, -7. So there it is in standard form. Might have to watch that a couple times. I know I made it go fast, but you know, it's what it is. Okay. Next one. Here we have, so what are they looking for again? All the same things. The vertex. Okay. All right. So in the x-intercept form, you really can't do much. Just at a glance, right? Like I can't tell the vertex just from looking at it, but there are some things that we can do. So we know that it crosses the x-axis at -5 and -1. Right? We know that for a fact. All right, so how many spots, how many units apart is 1 and 5? So 1, 2, 3, 4, 5. That's 4 units. 4 units. So that means the axis of symmetry is right down the middle at what? -1, -2, -3. The axis of symmetry is at x equals -3. X equals -3. Why is that significant? Why is it important to know that the axis of symmetry goes through -3? X equals -3. It's because the vertex will 100% lie on that line. So if I plug in x equals -3 into the original function, I'll get the vertex. So this is going to be -3/2 minus 3 plus 1 times -3 plus 5. So -3 plus 5 is 2, positive. -3 plus 1, -2. And that's being multiplied. And this is being multiplied by -3/2. All right, so let's see. A couple ways you could do this. Negatives are going to cancel, right? Negative times negative is a positive. This 2 and this 2 are going to cancel. That's because this is really over 1. You have a 2 in the top, a 2 in the bottom. So putting this all together, top times top, 3 times 2 is 6 over 1, which is 6. So that means the y component of the vertex is at 6. So the vertex, in conclusion, is at -3, 6. The domain, that's easy. It's always -∞ to infinity. unless there's a hole, and there's no hole, right? There's no hole, which we'll talk about that in rational functions. So right now it's always negative infinity to infinity. The range is going to be from the y component to one of the infinities. So does this open up or down? It opens down. So that means it's going to go from negative infinity to the max, or to the max, to the y-intercept. Well, it is the max. But what is the max, right? The max is the vertex. So the y component of the vertex. So 6 bracket. That's the range. Y-intercept. The y-intercept is when x is 0. So y-intercept is when x is 0. So if we let x equal 0, this is kind of nice. Because look what happens. This becomes 0. This becomes 0. So we get negative 3/2 times 0 plus 1 times 0 plus 5. So this is going to be negative 15 over 2. So the y-intercept is at y equals that value, right? At x equals 0, y is negative 15 over 2, which is about negative 7.5. Actually, it is 7.5, negative 7.5. Okay, we just have to write it in standard form. So off to the side, they give us no room to work. So negative 3/2, x plus 1, x plus 5. All right, so here we definitely have to FOIL this out, double distribute. There's no trick here. You have to actually do this. So this is x squared plus 5x plus x plus 5. So x squared plus 5 plus 6x, right? Combining like terms, plus 5. Times 3/2. Times 3/2. All this times negative 3/2. So negative 3/2 will distribute. So we'll get negative 3/2 x squared minus, when you distribute that, that's going to be 3 times 6 is 18. 18 divided by 2 is 9. 9x. And then minus 15 over 2. 15 over 2. So there's the standard version. Okay, the last one. It's already in standard version, so cool, I'm gonna do nothing. The vertex, however, we have a nice little formula. X component of the vertex is negative b over 2a. So in this case, negative b, so negative 12. Right, the negative 12 is part of the b. The negative that's out in front is part of the equation. 2 times a, which is 2. So negative times a negative is a positive. Sorry, so zoom in so you can see. It's a positive, so 12 over 4, which is 3. So the x component of the vertex is 3. To figure out the y component, we plug x back into the equation. So we get 2, 3 squared, minus 12 times 3. Don't get confused right here. All right, plus 12. This is going to be 3 squared is 9 times 2 is 18. Minus 12 times 3, 36. Plus 12. So combining like terms, 18 and 12 is 30. Minus 36. So negative 6. That's the y component. So conclusion, vertex is at 3, negative 6. 3, negative 6. That's vertex, and this is the at symbol. Vertex is at 3, negative 6. Domain, we're really running out of space here. The domain is going to be all row numbers. Bold struck R, all row numbers. And then the range is going to be, it opens upward. It opens upward. So from the minimum, the y component of the vertex, towards infinity, the y component of the vertex is going to be negative 6. up towards infinity because it goes upward. And the y-intercept, it's obvious, right? It's the c value. The y-intercept is 12. The y-intercept is 12. Okay, that was fun. So now let's do 14. Use the function below for 14a, 14b, and 15. All right, here we have. What is the domain of the function in interval notation? Absolute value is a continuous function, so it's always all real numbers. Unless there's a hole. There's no hole because there's no denominator that equals 0. We'll talk about that in rational functions. So just right now, just know it's always all real numbers. But in interval notation, we want negative infinity to positive infinity. That's the interval notation. Okay, the range, kind of similar to the quadratic, is going to go from the vertex towards one of the infinities. And remember that the inside lies. So the vertex is at positive 5, positive 6. Not only that, but it's negative, so it opens downward. So it's going to go from negative infinity, because that's where it's coming from, negative infinity, up to the y component of the vertex, 6 with a bracket. You might have to listen to that a couple times. But domain of an absolute value, as long as there's no holes, and there's no holes because there's no fraction, and negative infinity to infinity. And the range, it's always from the y component of the vertex towards one of the infinities, right? Either from negative infinity to the vertex or from the vertex to infinity, however you want to look at it. This one opens downward, so it's negative infinity up to the y component of the vertex. Okay. That 3 doesn't apply to anything right now. Well, now it does. Now we're going to graph it. So I'm just going to rewrite it over here. F of x, we'll define that as negative 3, x minus 5, plus 6. Okay. So the vertex we said was at 5. So to the right 5, and then up 6. So there's the vertex. We know it's going to open downward because it's negative. And then it's going to be vertically stretched by a factor of 3. So 1, 2, 3. 1, 2, 3. And we just keep this pattern going. Too easy, right? Too easy. Okay, last one. Let's go. So we have 4 different things. Okay, so a couple of... What do I notice? I notice that this is just a number. So that's a horizontal line, right? So think of this as your y. And it equals each of these independently, like separately, right? Y equals negative 2 is a horizontal line through negative 2, right? It's through negative 2. But then we have this restriction that says, hey, we don't want the whole line. I only want the part when x is less than negative 4. So x less than negative 4 with an open circle. So there's x equals negative 4. That's where it interacts with the line. I only want less than that. So all this other part is garbage. Trash. So there it is. Second one, again, this is nice, right? This is x or y equals, come on, bro. Y equals 4. Y equals 4 is another horizontal line through 4. I know I do that kind of ugly, but you get the picture, right? It's going through 4. But we don't want the whole line, right? It's a piecewise function. We only want a portion. So I want from x equals negative 4, close circle, to x equals negative 1, closed circle. Right. Well, two closed circles. Okay. Here we have a quadratic, negative x squared plus 2. Okay. Do this in black. So I want plus 2. I'm thinking. All right. So plus 2 is the y-intercept because this is standard form. If you want to look at it like that, it's in standard form. And then it's just going to open down. So x squared, right? X squared is just a standard parabola, opens upward. But this one's negative. So negative x squared, it's just going to open downward. And then we translate it, negative x squared plus 2. It just moves up 2. This is a crude drawing, but it's basically a parabola that goes up. So now, if you have the luxury of having me as a teacher, there's a very special technique that I like to do. So we need to figure out the right points left and right. Like, we just don't know how it's going to go. But I know that it's x squared, so it's not shrinking or stretching. So it's just basic. So the 45-degree angle line, right, from the vertex is definitely part of the equation. So this is going to be, what is this going to be? So the first line over, if you do 1 times the dilation, here the dilation, a is -1, right? A is equal to -1. So 1 times -1 is -1. So that's how, right, when you go over, I know how much to come down, and it's -1. So then to find on the next line, we use 4 times the dilation. So 4 times -1. So this is going to be 4 times -1 is -4. So I'm going to go down 1, 2, 3, 4, -4. You probably don't know what I'm referring to, so that's fine. Just rock with me. Just rock with me. So this is going to be an open circle, right? Because we're looking at the conditions, right? So -1. So at x equals -1, it's an open circle. At x equals 2, it's also an open circle. And now we connect the dots with the parabola. Okay, last one. It's a linear line. So -5 up 2 over 1. Okay, we're connecting the dots. But we don't want the whole line. We want when x is greater than 2. Closed circle on 2. So here's a closed circle. Let's erase the part that we don't need. All right, there it is. There it is. Hopefully, this helps someone and it gets to you on time. Catch you guys in the next video. Good luck.